So today I'm going to take apart and compare 4 of these drills, 2 Ryobi ones and 2 cheap Chinese knockoff ones. These were given to me and described as not working, but I think with most of them it's only batteries that are dead. This one even turns when you press the button. I arranged these in accordance to how I think they feel according to quality, with this one being the best and this one being the worst. This is my normal drill that I use for everything. It's one of these cheap skill drills. It came with 2 of these 12-volt batteries, and I use this for almost everything. This thing was €20 with 2 batteries, the drill and a bag. I bought it in Europe when Baumarkt or something was closing. And yeah, this is the drill that I use every day. I'm not going to take this one apart because I actually still want to use it someday, and I'm afraid that I might not be able to put it back together properly. But these we can open up and see if we can maybe replace the cells or something of the batteries if I have the chargers and stuff, and just see the different build quality and the different motors and stuff they use. These 2 drills are 18-volt drills and these 2 are 12-volt drills. So I think we'll start with this orange drill, 18-volt cordless 550 RPM drill, just made in China, and it has a normal nickel metal hydride, I think what I call it, NICD battery. First, remove the battery. The battery removes quite easily though. No issues removing the battery, and yeah. So this is the inside. It has quite a large 18-volt motor, a switch with a small MOSFET or something to drive the motor, and a battery connector. This MOSFET or transistor is a K2134 NEC transistor. So now I've just connected the motor directly with alligator clips to my power supply, and I'm going to see if I can get it to work. It's currently drawing 2.9 amps, and my power supply is current limiting because it's only a 3 amp power supply. Okay, with this one the battery struggles to remove. The clips just don't want to let go of the drill. Again with this design, battery connects on the bottom, switch, motor, and some MOSFET. This one is actually on a heatsink of some sort of heatsink. This is a STP45NF06 MOSFET or transistor, probably some MOSFET, and that drives this 12 volt motor. So now it's just again connected to my power supply, and I'm just going to slowly power or release the current on the power supply. It will probably top out at about 2.9, because that's a 3 amp power supply. It's now at 500 milliamps at 1 volt, 1 amp at 1.8 volts, two amps at 3 volts, and now the power supply is maxed. It maxes out at 2.8 amps at 3.8 volts. And this is the maximum I can get this thing to turn at. Sorry, 2.7 amps at 3.94-ish volts. And this is the maximum it's currently current limiting. And that's the maximum that my power supply can deliver. Next is the Ryobi 12 volts. Okay, this one's battery struggles to come out. Okay, the battery struggles a lot to come out on this one. Don't know why, but yeah, it does. Okay, this one as well, power connector, switch, motor. This one, the Ryobi ones, have an added bonus of choosing between power and draw mode. In power mode it has more torque, but it's not as fast, but this is great for when you want to use the draw for removing screws, like I do a lot. And the draw mode is, it has quite a lot of speed, but not a lot of torque. And like all of these draws there in front of have this ring that determines the amount of torque before it cuts out. Okay, so this is the first draw that does not have an external MOSFET or something. This one, all the power regulation happens inside this piece of plastic here, and that controls the direction, the speed and everything. It has no external MOSFET, and it has a lot of grease, which is probably a good thing. Okay, again connected to my power supply, starting from 0 amps. At 1 amp it's 1.3, 1.4 volts. Okay, now I'm at 2 amps and it's at 2.4 volts. Now it's at a maximum that the supply can deliver, which is a 2.7-ish amps at 3 volts. And this motor is not turning at all. Okay, now for the last one. It's quite a big draw, and the battery still has a little bit of power, but not a lot. Not even when I put it on a draw. First, remove the battery. Okay, I think this top silver piece is separate from the entire plastic handle. I think that has to come off first. Okay, from all the units I think this one has the largest motor. And like all the units, power connector, this one actually has an LED at the bottom with a switch. This is, I think this would be quite useful when drilling holes. I can't see a MOSFET or anything, so I think like the other Ryobi, everything is handled by the switch mechanism. And then the power just goes to the motor with a gearbox, and yeah. Okay, so giving it some power. 2 amps. It's at 1.9 volts. Now at full power, nothing. Nothing, nada. I wonder if these Ryobi things have maybe a built-in protection circuit. Maybe that's why they're not working. So I'm just trying to remove one of the leads connecting to the motor so that I can power it on. I think maybe this entire switch mechanism has some form of a power reverse protection or something like that. Wow. Okay. Now the one connection is loose. Now I can safely connect it to my power supply. Okay, so at 1 amp, it's at 1.2 volts. The motor starts about 1.3 amps. Yeah, 1.3-ish. Okay, the entire motor assembly comes out just like this. And you can read that number. This is the motor. 18 volts, made in April of 2008. I just have to put this cable back and then I can fix it. Then it should be fine again. This is just a switch to determine if you want to drill or use it to screw things in. It actually has a pivoting mechanism, which I think is quite smart. One thing to take note of is that these silver things cover up a few of the screws. Like, when you remove it, there are 2 screws here that are completely covered by this unit, so you have to remove these plastic things to open these drawers. So I might as well disconnect one of the cables here to test the motor as well, since it worked with the other drawer. At 1 amp it starts to turn. So I thought I might as well look at the battery when comparing withdrawals. This 12-volt battery goes with this drill, and let's have a look. Okay, this battery uses just a bunch of cells. Looks like these cells are just taped together. In total it uses 1, 2, 5, 8, 10. It uses 10 cells. These are probably 1.2 volt, 1,200 milliamp hour NICD batteries or cells. I'm quite surprised that it's actually just taped together, but yeah, whatever works. So this 18 volt battery, which isn't even marked 18 volts, nickel metal hydride, nickel cadmium batteries. Yeah, this one goes with this battery and with this drill, and it's supposed to be an 18 volt. Let's have a look. Okay. This is more or less the same design as the previous battery. I wonder if I use the same cells even. Yep, more or less the same. These are 1.2 volt, 1000 milliamp hour batteries, so not the same. These are just Liang Yi batteries, but this one uses 4, 5, 4, which gives 13, 14, 15. This one uses 15 cells, while this one doesn't. But this one sort of has a name brand, and these batteries are rated at a higher capacity, ones of a 12 volt draw. Now we get to the 12 volt Ryobi drills battery. Different shape, not the same connector as these. These batteries use more or less the same connector, although these batteries are not intercompatible. They physically do not fit into the other unit. But yeah, let's open it and see. Okay, this one has started to leak one of the cells. Probably some poisonous goo. Something to note, this battery has a connector here so you can charge it directly. You don't need to remove the battery each time, which is a good thing since this battery does struggle to remove. But most of these cells have started leaking, so I'm going to try and maybe replace them, but we'll see. This one has only one cell at the top, and in total it uses 2, 2, 2, 2, 2. So this one uses 10 cells in total. Yes, 10 cells to give you 12 volts. Just removing this cable. Okay. Okay, that was violent enough. Don't know if you can read this number. This is a D-SC1300P batteries. And like I said, there are, I think 10 in total, 4, 10 in total, so 1.2 volts each. And yeah, I think maybe I'll just take these batteries because I think these are still working, and put them inside the Ryobi drill because it's a much nicer drill to use. And some of these batteries are leaking, which is disgusting and I think poisonous. Yeah, probably poisonous. Okay, now I just have to recycle these batteries. Next is this monster drill and this huge 18 volt battery. Yeah, let's open it. Okay, this was simple enough, and this one doesn't even have a cell inside this piece like all the others do. Okay, this one has a bunch of cells. 15 cells, yeah. This one has 15 cells in total. They're directly connected to this connector, and these are 1300 1.5 volt, 1.2 volt nickel cadmium batteries or cells. So I would really like to use the Ryobi drill, but its batteries are completely fried and they're leaking, so I'm going to take the batteries from this 12 volt drill and just put the cells inside this the holder of the Ryobi drill. Okay, so this is how the batteries are connected. These go to here, then these two need to get connected, goes all the way around here. This cell needs to get connected by this, and then I need to connect a wire at the bottom as one side, and this goes to the other side, and then this cell also needs to get connected somehow. I will still have to figure this out, but yeah. I think I'm probably going to have to solder these. I know you should not solder on batteries, but I don't really have another choice, so yeah, whatever. To start off, I'm just going to use a bit of sandpaper just to create some surface area for everything to stick to. I'm just going to add some flux. Some flux using a toothbrush. And my soldering iron is set to about 400 degrees C. I don't really want to heat it up too long. I just want to be quick and get it done with. Okay, it's quick. Now just 2 or 3 more connections and then I'm finished. Okay, so I've started most of these already. Positive goes from here to here, and then this wire is the main negative, and this top battery has to get soldered onto this, and then the top will connect to the physical connector to the draw. So this is the final battery, well, almost finished. This just connects directly to the battery, and the stop part I had to solder to the battery. This connects to the bottom of one battery cell and just goes here. This indicator thing I still need to connect, but that won't be too difficult. And then the cover can just go on, so I'll quickly do that. I'm just going to connect it to my power supply, see what happens. It doesn't use a standard 2.1mm connector, probably a 2.5. Okay, so that was just a quick teardown and just to look inside all these drills, just look at the different types of mechanisms and stuff they use. I personally would not buy one of these cheap drills because the build quality just feels bad, and maybe if you use it once and not a lot, maybe it will work, but I really don't recommend buying one of these drills. Rather buy one of these Ryobi ones, and if they're too expensive, I haven't had any problems with my Skill Masters 12 volt drill. It works excellently, but then again I don't use it for very power and hungry and that difficult stuff like drilling to walls and stuff. I just use it to drill into wood and plastic and PCBs and remove screws. So that's it. If you like this video, please subscribe, and if you want, give me a thumbs up. Thank you very much. Enjoy the day.